Since it's a little bit more difficult to go from the name of a compound to its formula, I have a few more examples for you that we're going to look at today. The first one is zinc hydroxide. Zinc is a transition metal, but it actually only forms one charge. It's always going to be +1. So I'm going to start by drawing its picture. Zinc, Zn plus. And we got hydroxide. Hydroxide is actually on our list of polyatomic ions, and it is OH-. So I'm going to draw a neutral oxygen and a neutral hydrogen, but they are grouped together as a polyatomic ion, and overall they have a -1 charge. So we've got a +1 and a -1, +1, -1. So we actually only need one zinc and one hydroxide ion to get a neutral compound. So the formula is zinc, ZnOH. No subscripts on this one. If you did a crisscross method here, ZnOH, and you put the charges in, +1 and -1, and crisscross them, you would also see that we need one of each, and you would again get this formula. Second example, barium nitrate. Barium is in the second column on the periodic table. So 2A, it's going to have a 2+ charge. Nitrate, again here we've got another polyatomic ion. If I look it up by name, its formula is NO3-. Write that up here, you can see. So if we drew a picture of that guy, the NO3- consists of one nitrogen atom and 3 oxygen atoms covalently bonded together. So none of them alone have a charge, but that whole group of atoms as a whole, as a polyatomic ion, have a -1 charge. So right now we do not have our charges balanced out. We have +2 and -1, so we have more positive, and to get the balanced out we're going to need a second negative. So I'm going to draw another NO3 group here. So NO3, and that whole group has a -1 charge. So now if I look at my charges, I have -1 and -1, which gives me -2, and +2 for the barium, so we have an overall minus charge. Here's a little trick on writing formulas for polyatomic ions. We have I drew one barium atom, and I drew 2 of the NO3 groups. So we're going to use parentheses to show that the NO3s are grouped together, but we have 2 of them, 1, 2. So this 2 here means that we had to draw that NO3 group twice. If we did the crisscross method with that, barium and NO3, the barium has a 2+ charge, the NO3 has a -1 charge. So if we crisscross here, just the numbers, not the charges, you again end up with a formula that's barium with a 1, we don't need to write that, and NO3 with a 2. So you're getting the same formula either way, but you need to understand how to draw the pictures. The last one I put on here for a reason, I want you to notice there is one and only one polyatomic ion that has a positive charge. So you might just want to recognize or come to recognize that ammonium is actually a polyatomic ion. It's not a metal. This guy's interesting because ammonium sulfate actually is all nonmetals, but it is an ionic compound because it's made of 2 polyatomic ions. Ammonium is NH4+, and sulfate, if you look that up, that's also a polyatomic ion. It is SO4 2-. So lots to draw in this picture here. I'm going to need a nitrogen with 4 hydrogens around it. And that group of atoms has a +1 charge. And I'm going to draw a sulfate polyatomic ion, a sulfur with 4 oxygens around it. And that whole group of atoms has a -2 charge. So our charges are not balanced. We've got more negative than positive right now, so I need more positive. I'm going to draw one more in H4 group, one more ammonium, and that again has a +1 charge. So now we've drawn -2 and 2 positives, so we've got a total charge of 0, which is what we're shooting for. So our formula will be NH4, and I'm going to use parentheses to show that I had to draw 2 of those, and then SO4. That is the formula for ammonium sulfate. Now at this point, it's up to you guys. You're going to have to do a lot of practice to get really good at naming and going both ways, formula to name and name to formula. So good luck.